Solve the following system of equations by using a matrix. Okay, so I have here three equations and three variables inside my solve the following system of equations by using a matrix. So here we have a system of equations that has three equations and three variables. So this is considered to be a large system. And in order to solve a large system, you can use things like substitution and elimination. However, it is a little bit difficult in keeping track of all the different things you need to do in order to solve it, and it's easy to get lost. So we use a more generalized process called the Gauss-Jordan method, which requires us to change our system into what's known as an augmented matrix, which is a matrix that has the same number of rows as equations and columns plus one as variables. So for instance, I can make a matrix here that has coefficients of 1, -2, 3, and then I'll put a bar here and then a 1. So that represents the first equation as a matrix row. And our matrix rows are defined by multiplying the coefficient on x, the coefficient on y, and the coefficient on z, and then equals some constant. So this bar is representing the equals. All right, so the next equation turns into 2, 1, 1, 4. And the last one is 4, -3, 7, 6. Okay, so next what we would do is for Gauss-Jordan, there is a process that we can follow, but it's actually rather involved and tedious as well, and very prone to error, very prone to arithmetic error, that is. So we'll let the calculator help us out here. And in order to work with matrices in the calculator, you can hit the second key and the x to the -1, which will take you into the matrix menu. Then just slide over to where it says edit and pick any matrix you want, but I generally just use matrix A, and define the size of it. So here I have 3 rows by 4 columns, so 3 by 4 is perfect. And now I can just start entering the coefficients of my new system. And just make sure you're careful as you type these in, because the only way really to get incorrect answers in the end is to mistakenly type in the wrong coefficients as you go through this process. Okay, now once you're done, quit out of the matrix editor, but then go back into the matrix menu, and this time slide over to the math menu, because what we're looking to do is some operations based off of this matrix. So the operation that we want here is RREF. So it stands for row reduced echelon form. And that is different from the function REF, so make sure you get the correct one. So select that function, and you should see it back on the home screen. And it requires you to say which matrix you want to plug here. So we want to plug in matrix A. So just highlight matrix A and press enter. Then close parentheses and run the program. So now what it does is it gives us the output of the Gauss-Jordan method. So what I'm going to do is copy that output back over here so I can work with it. So I've got 1, 0, 1, and then 1.8, 0, 1, -1, and 0.4, and then a row of all zeros. Now, if you're required to use exact answers, one thing that you can do for these decimals is change them into fractions by if you hit the math key, and you have the very first item that says a triangle frac, and it will change your decimals into fractions, which could be a big help. So let's actually do that. Let's make that 1.8, let's change it to 9/5. And the 0.4 changes into 2/5. All right, so that's a little bit nicer. And let me tell you what, let me write it like that so I can fit it. Okay, so changing this back into a system of equations sort of helps us reveal what the solution actually looks like here. So everything in the first column is multiplied by x, everything in the second is multiplied by y, and then z, and then we have equals a constant. So when I change this back to a system of equations, it's going to look like x plus z equals 9/5, and then y minus z equals 2/5, and then everything in this last row is zeroed out, so we don't really need to put anything because we would just have 0 equals 0. Now, that's not an indication that there's no solution to this system. Basically, what that tells us is that there's infinitely many solutions because it's not a contradiction, like if we were trying to say 0 equals 1, for instance, something like that. Now, since we know there's infinitely many solutions, how do we express that? Well, every time we have any solutions at all, we need to express them as a coordinate triple since we have 3 variables. So we need something solved for x, y, and z. Okay, well, I could get something solved for x and y because I could just rewrite these equations as x equals something. So negative z plus 9/5 and y equals positive z plus 2/5. All right, so that I can actually just put in for x and y. So negative z plus 9/5 and z plus 2/5. But then the question is, what is z? Well, z is a free variable. You see how it ends up in an equation for x and y? So what that means is you can pick anything you want for z, and it will turn out that whatever you choose there, x and y will become accordingly values that will solve the system. So the answer to what do we use for z is, well, itself. Because we can just pick whatever we want here, and then whatever we choose here will affect what the answers are for x and y. So for instance, if I chose z to be 0, for instance, if I chose z to be 0, then what happens is x becomes 0 plus 9/5, and y becomes 0 plus 2/5. And so this right here would be a solution to the system. So whatever we pick for z, we could always get a solution to the system in that way. So this is how we use a free variable to get our final answer.